In many situations, we would like to study the relation between two variables. One variable, the independent variable, I put the name x for this variable, and another variable y. And we would like to see the relation of this. The first idea is to make a graph. If we make a graph, the best graph for this is the scatter diagram. The scatter diagram shows in points if of the pairs of value here, x and y. For example, this 1, 3, 5 is represented by this point here, the point A. And each of these pair of values have a representation in one of these points. If I see this graph, I notice that the greater the value of x, the greater the value of y. What I'm going to do to study this situation, or what people usually do for study this situation, is to find the line that best approximates this point. This is the line that we call the regression line. And what I'm going to show you today is how to use matrix algebra for doing that. The line that we are going to find will be of this form: y equal ax plus b. This is the form of whatever line. And to find a line, to define a line, what we need to do is to find these two coefficients: a, that is the slope of the line, and b, that is this point here, the intersection of the line with the y-axis. So what I'm going to do is to assume that these points satisfy this line. Obviously, you can see that they don't satisfy the line, yeah? But we're going to assume if this point satisfies the line, so every of these points, if I replace x by 3, the value here of y will be 5. So 5 will be equal to 3a plus b. If we substitute this x by 3, that will be the situation. And if the second point satisfies this line, then it's going to be 2a plus b equal 1, for example, in this case. 2a plus b equal 1. And then the next one will be x plus b equal 2, for example. Or 1a plus b equal 2, etc. So each of these points, and you don't need to do this, by the way, but we are going to assume that this is happening, that each of these points satisfy the line. So if that were the case, that will be the system of equations that I have. In this case, we have 15 values, so there will be 15 equations. And obviously, in this situation, I notice that there won't be solution. So it's impossible that there is a line that passes through all these points. So we are assuming something that is false. But we're going to start from there. And obviously, if that is true, then this matrix equation is true. So remember how to pass a system of equations as a matrix equation. Actually, finding AB will be solving this. And I know if I solve this, there won't be solution, because if there were solutions, so it means that there will be a line that passes through all these points. And there is not a line that passes through this point. But I am assuming that it's true. But I can modify this in such a way that we can find a solution. So let's see. This column of 1s is because all this value here, the value of b, appears multiplied by 1. And all the values of x appears multiplying the first coefficient a, the slope. So for that reason, for example, if I choose the first row, will be 3a plus b equal 5. If I get the second row, 2a plus b equal 1. So actually, this matrix equation represents all these equations. So actually, what I have, if an equation x, let's call this matrix x, capital X, multiplied by this vector of coefficient equal this vector of values of y. So what I have is this, that I know doesn't have any solution. But what I'm going to do is multiply this system of equation by the transpose of x. If I do that, I'm going to left multiply, so it will be x transpose of x multiplied by a equal x transpose of x multiplied by b. So far what I have done is multiply by the transpose. And I notice that if I do that, if I multiply by the transpose of x, now this matrix here because the multiplication of matrices satisfy the associative law, so I can multiply these two first. If I multiply x transpose times x, look at that, x transpose x, the size of x is n rows, in this case will be 15 rows, 2 columns. The matrix x transpose will be then 2 rows, 15 columns, of 2 rows and columns. So when I multiply these two, the size of this matrix will be 2 by 2. And these have two values, a and b, that I'm looking for, two unknowns. So we have a 2 by 2 matrix multiplying a vector of 2 by 1. So the answer will be a vector of 2 by 1. And x transpose will be a matrix of 2 by n, and this will be a matrix of n by 1. So this, remember that B is a vector of n rows, 1 column. So this is an equation that could have solution, and actually has solution in many cases. Anytime that x transpose multiplied by x have an inverse, then we can find a solution. And that's what we are going to do. We are going to multiply now both sides by the inverse of this matrix. The inverse of this multiplied by this will give me the identity. So at this side we have only a, and at the other side we're going to have the inverse of this matrix multiplied by what I had to the right side. So if the inverse of this x transpose x is 6, then this will have a solution, and this solution will be the value of a and b. So it can be proved that this is the line that best approximates this point. So this is the regression line. So in this way, you just need to learn only one equation. So this is the importance of this. There is only one formula to find the regression line. In a linear model, where we have more variables, we have more independent variables, and even in that type of models, we can use this equation. Any linear model can be solved using only one equation. And if you have a software that can solve this equation, so it will be an easy problem finding the regression line. As an example, let's find the least square regression equation that we saw in the previous slide, and then approximate the value of y when x equals 11. So we know that we have the value of x, the value of y, and we can make a scatter diagram of this value, and what we are going to do is to find the least square regression line. And for doing that, we know that we're going to have a matrix. We're going to assume that will be a matrix that will be a matrix that will have a column with all the values of x and a second column with only ones. If we have more independent variables, we can actually make a biggest x matrix. And a matrix y, that is only a column vector, and these are all the values of y. We know that we are going to find a vector of coefficients. In this case will be only the slope and the intercept, so it will be a matrix of the form a, b, where a will be the slope and b will be the intercept. And I know that there is a formula to find it. It's just making the inverse of the x transpose multiplied by x, the inverse of this multiplied by x transpose y. If we have a software that can compute transpose, that can compute inverse, and that can make matrix multiplication, this is just one line. So let's do it. We have r. We know that these are the values. This is the formula that I'm going to use. Then I open R. If I open R to solve it, call the package Pragma that can allow you to make the index of a matrix and compute determinants and make many things. So I'm going to call Pragma, so I'm going to type library will be the command, and open bracket open quotations and type Pragma, close quotation, close bracket, and press enter. After you press enter, R is ready for you to enter whatever you need. So for example, I know that there is a matrix X, so I'm going to input this matrix X. So it will be X equal matrix, and type the whole column 3, 2, all the values, and remember that the last column will be only ones, will be 15 1 that you need to type. You need to tell R that there are 15 rows and 2 columns and press enter. You can type X and Y in the same line separated by semicolon. But let's type Y now. Y will be just one column, so it will be a matrix of 15 by 1. So you're going to type Y equal matrix. Again, remember the C of combine, and then there is only one column. So type all the values, and then 15 and 1. 15, the number of rows, 1, the number of columns. Remember, the command is matrix for making a matrix, and C for combination. So you're going to combine the columns. So you will need to separate the column by comma and the entries of the column by comma also. In this case, there is only one column, but you need to type C at the beginning, open bracket and all the elements of the columns. In the first matrix, I type C, type the first column, and when I finish with the last element of the column, that was 7.6, then I type 15 ones. So that gives me the elements in the second column. This matrix X has all the values of the column X and a column of 1 at the end. And after you have X and Y, you have everything that you need to find A. So you can type enter, and now that you type enter, now R is ready to do whatever you want with this X and Y. And what I'm going to do is the inverse of this matrix. So I'm going to type A will be equal the inverse of the transpose of X multiplied by X multiplied by the transpose of X multiplied by Y. So you see, I put the bracket here to get the inverse of the transpose of X multiplied by X. Remember, this multiplication sign enclosed by these 2% signs means for R that you are making multiplication of matrix multiplication. After I compute the inverse of this, I need that R multiply this by the other matrix. I put the other matrix in bracket, so multiply by the transpose of X multiplied by Y and close bracket. You enter, R have already solved the problem. So now R knows what is the vector A. If you want to see the vector, just press A and enter. So you see that the value of A is 0.642363, and the value of B, the intercept, will be 1.113989. So you can say then that the line that you were looking for is this line, 0.646, I rounded to 3 decimals, plus 1.111. This is the slope, this is the intercept. If you want to answer the second question, what will be the value of Y if X equal 11, the only that you need to do is make a substitution here. So it will be, if X equal 11, then Y will be 0.646 multiplied by 11 plus 1.111. If you have R, do it in R. If you have a calculator, do it in a calculator. The answer I get was 8.22. If you see the graph that we get before, you will notice that when the value of X is 11, the value of Y is around A. We know that the value of Y is 8.22. So this approximates the situation when X equal 11. With this, I have finished to explain how to use matrix algebra for finding the least squares regression line. So the line of best fitting of the points we have. I hope you have found this video useful. Thank you.